Hey you guys. Okay, so the second big idea, or I guess the third big idea that we're kind of looking at here is how we find the area of regular polygons. Now, we have a specific formula that we use for this, and our specific formula for finding the area of a polygon that is regular is we take 1/2 and we multiply it A times P. Now, A is a new idea for you guys. A stands for the apothem. And the apothem is the length from the center of a polygon. So, for example, we have our polygon, pentagon down here. Here's the center, okay? And then it is the length from the center of the polygon to one of the edges. Now, no, it is not to one of the vertices, because that would be the radius of the circle that surrounds the regular polygon. What this is the apothem is the length from the center to one of the edges. And we know that it is the apothem because it goes obviously to one of the sides, but most importantly because it creates this right angle. So it essentially is the height of the triangles that we were separating earlier. All right, now P, of course, is our perimeter, and perimeter is the total distance around our polygon. So whenever we look at the length of one of the sides, we can multiply that by 5, and that'll give us our perimeter. When we multiply that times our apothem, whatever that is, divide it by 2 or multiply 1/2, that will give us the area of this polygon. Okay, so one of the things that we're going to have to do is we're going to have to go back to how do we solve a right triangle. And we have different ways for solving right triangles, so we're going to go ahead and look at some of them here. All right, the first thing I'm going to do is I'm going to determine what my central angle is. So I'm going to figure out that I have 1, 2, 3, 4, 5, 6 triangles there. If I take apart my center piece here, I'm going to have 360, and I'm going to divide it by 1, 2, 3, 4, 5, 6 triangles, which equals 60 degrees. So each one of these guys is going to be 60 degrees. Now, in order to determine what the area of this polygon is, I need to figure out what is my apothem, and I need to figure out what is my perimeter. So my A is going to stand for my apothem, my P is going to stand for my perimeter. So what I'm going to do is I'm going to take this little triangle that I've made, and I'm going to pull it out, okay? So I'm using the information that they give me, that this is 20 inches. I know that I need to find my height, which is going to be my apothem. And then I know my base here, excuse me, is going to be 1/2 of the length of this, okay? So then that's my base. Now, because I identified the fact that each one of these triangles up here is 60 degrees, that means that this one here is 30 and this one here is 30, which means that this angle measure there is 30 degrees. Okay, now we have two different options how we solve a right triangle here. We can use our 30, 60, 90 rule, because we know that this is 30, that's 90, so this has to be 60, and we can use our 30, 60, 90 rule to determine what is the long side, the short side, and our hypotenuse. The other thing that we can do is we can use our trigonomic ratios. So we can use the sine, we can use the cosine, and we can use the tangent. Now remember, the sine, if we remember SOHCAHTOA, the sine is our opposite over our hypotenuse. Our cosine is our adjacent over our hypotenuse, and our tangent is our opposite over our adjacent. I like using the trigonomic ratios because they work for all right triangles. Okay, it doesn't matter if we have 30, 60, 90. Then you don't have to mess around with those 30, 60, 90 rules. So what I'm going to do is I'm going to solve for A here. All right, and I'm going to use my 30 degrees here. And because I'm solving for A, this is my adjacent because it's next to it. Here's my hypotenuse. So we have adjacent and hypotenuse, which is the cosine. So I'm going to say that the cosine of 30 degrees is equal to my adjacent, which is A, over my hypotenuse, which is 20. All right, now I can go through and I can solve here. So I need to multiply both sides by 20. Multiply by 20. Those cancel. And now all I'm left with is A equals the cosine of 30 times 20. So pull out your calculator. Cosine of 30 is 8600ths. Multiply it by 20. And it gives me 17.32. So my A equals 17.32. All right? Okay, so now I can plug that into there. Now what I need to do is, now I'm looking for the perimeter. So the perimeter, remember, is the lengths around and however many of them you have. So what I need to do is I need to find my short guy down here. And so now we can call this, I don't know, Y if we want. It doesn't really matter because it's just going to go up here. So now I'm looking essentially for the opposite of 30 over the hypotenuse. And the opposite over the hypotenuse is the sine. So now what I'm going to do is I'm going to say the sine of 30 equals my opposite, which is y, over my hypotenuse, which is still 20. And now I can solve for y. So I'm going to multiply both sides by 20, multiply by 20. Those cancel. And now I figure that y equals the sine of 30 times 20. So let's use our calculator. So I have the sine of 30 equals 5/10 times 20, which equals 10. So y equals 10, which means that this short side here is 10. Now, I can't multiply 10 times 6 because 10 is not the length of one side. 10 is just the length of this part of the right triangle, which means that this is 10 as well, which means that all my lengths are actually 20. So my perimeter is going to be 20 times 6, or 120. Finally, I'm going to go through and I can solve for my area. So my area equals 1/2 A times P. And so my area equals 1/2 17.32 times my perimeter, which is 120. And so my area, I'm just going to take 1/2 of 120 and do 60 times 17.32, and that's going to be my area of my hexagon. So let's do 60 times 17.32, and that gives me 1039.2. So my area of this polygon equals 1039 200ths. We don't have units, so we'll call it units squared. Okay? All right, that's example number 1. Let's go through example number 2. Okay, example number 2 gives us also a polygon, and we're going to have to count how many sides we have on here because it's a lot. This is a regular polygon, so I'm going to start in here, and let's determine how many triangles we have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and our central here is always 360. So we have 360 divided by 9, which is 40, which means that each one of these guys is going to be 40 degrees. All right. Now this triangle gives us the distance of one of the lengths on the bottom, but we still need to do our part and find our apothem, which remember is the line that comes straight down from the center to one of the edges. Now, when we do that, what we're going to look at is we're going to pull our right triangle out. If this whole thing is 715, I know that my bottom is going to be 7.5. I know my height is going to be my apothem. That's what I need to find. And then here, we don't necessarily know our hypotenuse, all right? But we do know that we have a right angle here. We know that this whole triangle up here is 40, which means that half of it is going to be 20 degrees. Now what I can do is, I don't need to find my hypotenuse because I don't really care. I don't need that for the area. But what I do need to find is my height here. So what I'm going to do is I'm going to use my trigonomic ratios, and I'm going to use my adjacent, and I'm going to use my opposite. So my adjacent, my opposite is the tangent of 20 degrees equals opposite 7.5 over adjacent, which is A. Now I need to solve for A. So I multiply both sides by A to get rid of it in the denominator on this side. Those cancel. And now I'm left with A times the tangent of 20 equals 7.5. Still solving for A. So what I can do now is I can divide this side by the tangent of 20, divide this side by the tangent of 20. Those cancel, and I'm left with A equals 7.5 divided by the tangent 20. And let's see what that is. So the tangent of 20 is 36 hundredths, or 364 thousandths. Alright, that's a tangent of 20, so remember that. So 7.5 divided by 0.3639 gives me 20.61. Okay, and we're in feet. Alright, now that makes sense to have this be 20.61 because it has to be greater than this. So my apothem is 20.61, and now I can find my perimeter. Well, my perimeter was just, the length here was 15, so I know it's 15, and then how many sides do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, so 15 times 9, and that is going to give me 135. So my perimeter is 135, my apothem is 20 and 61 hundredths. Now I can solve for area. Area equals 1/2 A times P. Area equals 1/2 of 20.61 times my perimeter of 135. Area equals, I'm going to do 135 times 20.61 divided by 2, which gives me 1,391 point, let's call it 18 feet squared. And that's my area of that 9-sided polygon, or my nonagon. Okay. All right, one more here. What this one is saying is it wants you to find the area of the shaded region. Well, I know that my drawing isn't perfect, but that shaded region on the outside of that pentagon is a circle. So in order to find the area of the circle, we have to figure out what the radius is. Now, the radius is the distance from the center to any of the vertices. So we have to do two things here. Number one, we have to find the area of the circle. Number two, we have to subtract the area of the pentagon. Okay, so we can't find the area of the circle until we figure out what the radius is. And we can't figure out what the radius is until we do a little bit of this work. So 1, 2, 3, 4, 5. We have 5 triangles in there, and so we need to divide 360 divided by 5, and I think I said that was 72 earlier. Yeah. Okay, so each of these guys in here is 72 degrees, which means when I go through and I drop my apothem in here to determine that, this little guy is going to be 36, and this is going to be 36. Okay, now the distance here is 12, which means that when I pull out my right triangle to make it more workable, this is going to be 6 here, and this is going to be 6 here. So I can drop my 6 there. Now I need to find my apothem, so I'm going to be looking for A here. And I also have to find my radius, which means I have to find my hypotenuse, because I have to determine what the area of the circle is. If I didn't have to find out what the area of the circle was, the radius doesn't necessarily take precedent. It doesn't matter. All right, so I know that my angle there's 36, so I can use, I have to use my 6, which is my opposite. So I can use, if I'm solving for A, we can use the tangent. So I'm going to say the tangent of 36 equals opposite over adjacent. So I'm going to have my opposite, which is 6, over my adjacent, which is A. And now I go through and I solve for A. So I'm going to multiply both sides by A to get out of the denominator. Now I have A times the tangent of 36 equals 6. Divide by the tangent of 36 on both sides. Those cancel. I'm left with A is now equal to 6 divided by the tangent of 36. So the tangent of 36 is 0.7265. So I have 6 divided by 0.7265, and that gives me A equals 8.26, we'll call it. All right, so my apothem is going to be 8.26, and now I need to solve for my radius. So I can use my trigonometric functions again, and I can use my 36 degrees. I'm going to use opposite over hypotenuse just because I don't want to deal with decimals. So my opposite over hypotenuse is going to be the sine of 36 equals 6 over, I'm going to call it R for radius. And now I go through and I do the same exact thing. So I multiply both sides by R to get rid of the denominator over here. R times the sine of 36 equals 6. Divide both sides by the sine of 36. Those cancel. And now I'm left with R equals 6 divided by the sine of 36. The sine of 36 is 0.5878. So I do 6 divided by 0.5878. And I get 10.21. Okay, now that makes sense, and that's good. Okay, because we have a 6, 8.5, and 8.25 and almost 10.25. Our hypotenuse is the longest one, which means that our radius here is going to be 10.21. So what we need to do is we need to find the area of the circle equals pi times r squared. So we're going to have equals pi times 10.21 squared, which is 104.19. So we're going to have pi times, oops, let's go back. Okay, times pi, which equals 327.49. All right, that's the area of our circle. So that's number one. The second thing we need to do is we need to go through and now use our formula here for the area of the pentagon. And that is going to equal 1/2 A times P. So 1/2 8.26 times our perimeter. Now our perimeter is 12 times 5. So perimeter equals 12 times 5 sides, which equals 60. So our perimeter is 60. And now we can go through and figure out that really this is going to be 8.26 times 30. And that is going to give us 8.26 times 30, 247 and 8/10. We're dealing with centimeters squared. All right, now we have the circle area. This was number 1. Area of our pentagon was number 2 from our original directions up here, right? Now what we can do is we can subtract. So I'm going to do my shaded region is going to be the area of my circle, which is 327 49/100, minus the area of my pentagon, which is 247 8/10. And that is going to tell me what the area of my shaded region was. So let's do 327.49 subtract 247.8. And that is going to give us the area of my shaded region, which is 79.69 centimeters squared. And that is my final answer. Okay. All right, so that is area of regular polygon. Thanks, guys.